Let us know that what's the marks distribution, because this year it has quite changed. Okay, like last year it was like so complete 30 marks is in our hands now. Hi guys, welcome back to my physics class. So as you know that your physics practical dates are very close, so let's have some physics practical preparation. Okay, so firstly let us know that what's the marks distribution, because this year it has quite changed. Okay, like last year it was like completely like you had a viva and all. As you know that this year we don't have any viva. Okay, so we have like 20 marks we have for written as well as performing the experiment, and 5 marks for record, and remaining 5 marks is for attendance. So attendance is very important, and even the record is also very important. Okay, so complete 30 marks is in our hands now. Okay, so now let's prepare for 20 marks. Okay, remaining 10 marks is in your hands. So next 20 marks is like something which we can guide you for that. Okay, so now yeah, I have selected, like you have many experiments. Okay, I have selected few experiments. Okay, so before that let us know the distribution of marks. As you know that duration of practical exam is for 2 hours. Okay, and maximum marks is 30 as I said. Okay, but now this year like 20 marks completely written exam. Written as well as performing the experiment. So firstly let us know that. Okay, please write it in the proper same sequence, like you start from the principle and then formula and then the circuit diagram or figure in case if it is, and then comes observation, tabular column, calculation, and then result. Please end it with result. So these complete marks thing carries 20 marks. Okay, in case if you miss result also -2. So please don't do that. Some students like they would have completed the experiment, okay, but they would have forgotten to write the complete proper result. Okay, so they will lose 2 marks. So please don't do such silly errors here. Okay, so as I said, like principle carries 2 marks. So every experiment you should be learning the principle. Okay, and then the formula. Okay, so now like there are some experiments where there is no formula, but in that case what happens, there is a tabular column, calculation, observation, and we have graph also, right? So there the marks will be given. Okay, and like for example forward bias, reverse bias, and all. Okay, and then it's a circuit diagram. There might be a circuit diagram, if not just a figure where you'll have to label that figure. Okay, that carries 2 marks. And then the observation pattern. Okay, writing the tabular column or observation pattern, how you are writing the observation, that carries 2 marks. And constructing the circuit. Okay, so where it depends on you, like how you construct the circuit, so that carries 3 marks. And then performing the experiment, yeah, remaining 4 marks. Substituting, calculation, and the graph, it carries 3 marks. And final proper result carries 2 marks. Okay, so these are the mark distribution of marks, and total it is 20 marks. Okay, now first let us discuss resistivity of material of wire. Okay, so they'll be giving a wire to you. You will be finding the resistivity of it. Okay, so this experiment and then the next experiment, that is resistance per unit length, both have the same circuit diagram. Okay, so now you need not write the aim, apparatus and all. Apparatus is also not required, but in case if you know, you can just see what all apparatus are given in your place. You can write that. And as you know that it's like a lottery system. You will pick one experiment, okay, out of 10 experiments. In case minimum, they'll have to like 10 experiments. In that, it's like one you will be selecting it. It's basically like a lottery system. Okay, so now start from the principle. Okay, as I said, both the experiments have same principle. That's Ohm's law principle, where you have already learnt in your theory. Okay, what is Ohm's law? Just state Ohm's law, then write what is a formula here. Okay, so in this case resistivity, right? So you know the resistivity formula, like R equals rho L by A, where rho equals R times L by, okay, RA by L. Okay, so you can write this resistivity formula. So first find the resistance, and there's no graph for this. So you will construct the circuit diagram. Please draw the circuit diagram, and then the observation where radius will be given. You don't worry about that. Length you can measure, but radius you need to have a screw gauge, right? So basically it will be given. Radius will be given, or diameter will be given. Okay, diameter of the wire will be given. So directly take the readings of current versus voltage using the rheostat. Just move the rheostat. The voltage and current will vary after you construct the circuit, and then just write down what is the resistance, calculate the resistance of it. Okay, and then take a mean value of the resistance. Whatever the resistance value you are getting, substitute in this formula. Okay, where the pi value is 3.14, radius will be given, take a square of it, and then resistance is what you found through the experiment divided by L, length of the wire. Okay, in case if they are giving length as 1 meter, put it in meters, and if you are measuring it in centimeter, please convert to meters. Okay, everything convert to SI system. Only then final answer you will get it in rho will be dash times ohm meter. Okay, so please know what will be the range of the value, like in case if there is a nichrome wire. Okay, basically we use nichrome wire. Okay, it's like 1.1 into 10 raised to minus 6 ohm meter. So these are some of the standard values. Please know the standard value. In case if you're getting the correct answer, okay, you can end the experiment with confidence. Okay, so that errors also matters over here. In case if there are 0 errors, yes, the over there also the distribution of marks matters. Okay, you can't get some different values over here. You should, that those values should be within that range. Okay, fine. So now moving to the next, as I said, same circuit diagram even for this. So this experiment name is resistance per unit length of the wire. Okay, here you are not finding any resistivity. Okay, as I said, the same experiment, everything is the same, principle is the same, formula almost, yeah, formula you can just take here, resistance, right? So just through graph you will be finding the resistance. Okay, here you are not substituting in any formula. Okay, but still you should write the formula. Don't skip this formula part where you will write what is R equals 1 by M, where R is resistance of the wire, M is slope. Okay, through this finding the slope you will be finding the resistance. Okay. So please don't forget to write the formula. Don't think there's no formula, not write. No, you should write the formula because formula also carries marks over here, and you should name the terms. Whatever is there in the formula, name the terms. So this will like complete marks, you can get it from here. Okay. So as I said, same circuit diagram, please draw battery over here. Okay. And then plug key, and as you know that ammeter is always connected in series. Remember, ammeter is always connected in series and voltmeter is always connected in parallel, and it is connected to rheostat. Okay, rheostat is something where we vary the resistance. Okay, so as you vary the resistance, what happens? There will be a voltage and current. Okay, there is a variation of voltage and the current. So just take some, in case if you're plotting a graph, take around 5 to 6 readings. As you increase the reading, you can reduce the errors, as you know that. Okay, so as you take the like increase the number of readings, okay, and then plot a graph of I versus V or V versus I. Okay, if you're plotting a graph of yeah, here it is I versus V, so you will be getting a slope over here. Okay, I'll just show it once. Okay, so this is a graph of I versus V. Okay, the slope of the graph can be taken as AB by BC. Okay, slope is taken as AB by BC. As you all know how to take a slope, whatever the values are near the A, difference of B divided by B and C, the difference you will be taking it. Okay, so in case if for example, in case this is 2 and this is 4, and here I'll just take it as something like 6 and 4 or something. Okay, so what is AB value, guys? AB is 4 minus 2 divided by, here it is 6 minus 4. So 4 minus 2 is 2, 6 minus 4 is 2. Again, you will be getting 1. Sorry, yeah, slope is 1. You can just take it as 1. Okay. Okay, slope is 1. But how to find the resistance with respect to slope in case of I versus V means resistance is 1 by slope, guys. Okay, so 1 divided by, okay, even slope is 1. So finally you will get resistance as 1 over here. Okay, so remember this, don't do the mistake. And mainly we are taking milliammeter. Okay, in most of the experiments we take milliammeter because the current is very, very small over here. That's the reason we'll be taking milliammeters. In case if you are taking milliammeter, don't forget to take this in terms of milliamps. Okay, so current, as I said, AB is current, right? So 4 minus 2, this will be in terms of milliammeter. So finally answer will be in terms of milli. Okay, so but here 1 by slope it is 1 by milliamps. Is 1 by 1 milli is it 1 milli? No, right? So 1 milli, if it goes up, what happens? It becomes 10 power 3 because milli means 10 raised to minus 3. As it goes to the numerator, it is 10 power 3. So finally answer will be in terms of 1 into 10 power 3 ohm. Okay, so please don't forget this because most of the experiments we take milliammeter. Okay, so you're finding the resistance over here. Okay, you're finding the resistance, but what's the aim of this experiment? Resistance per unit length of the wire, right? So final result you can see here, observation you would have taken in case if there is a 1 meter, okay, in case if they have given 1 meter, I'll write it as 1 meter, but still please measure the length, okay? And then yeah, as I said, vary current versus voltage, resistance of the wire. This will be the calculation. Again here, don't think there's no calculation. Of course, the graph is also a part of it. Okay, so whatever the calculation is there, please show it with proof, because here we will be allotting the marks for each and every step. So please don't forget this. Okay, don't think, okay, I'll do the calculation, I'll just enter the final result. Please don't do that mistake. Whatever you are calculating, there should be a proof. So please do it in the same worksheet. Same paper. Okay, and finally, resistance per unit length of the wire. Okay, in my previous, what I said, I got around 10 power 3, right? Here, I'll be taking it as 10 power 3 per unit length. Length, if it is 1 meter, 10 power 3 by 1 is 10 power 3. Write as ohm per meter in your result. Okay, because it is resistance per unit length. They're not asking only to find the resistance. They're asking you to find resistance per unit length of the wire. Okay, sometimes the length will be in 50 centimeter. Okay, so please convert that 50 centimeter like 0.5 meters. Okay, always you should convert it to meters. So if it is 50 meter, 10 power 3 by 0.5. Okay, so like this you have to do, and final result you should enter here. So finally the result is what? The result is resistance per unit length of the wire is dash ohm per meter. Okay, so this will end your experiment. Only then you can gain complete 20 marks over here. So please be confident about this. Since you don't have any viva, you don't have to worry about anything. Okay, so if whatever you write matters over here, and how you construct the experiment and how you are performing the experiment, everything matters. So please know what the final result, what should be the final result, roughly have some idea on this. Okay, fine. So now we'll, as I said, next is figure of merit experiment over here. Okay, so figure of merit, please, yeah, it's almost the same principle where deflection is directly proportional to the current through the galvanometer, and then the formula K equals E divided by R plus G of theta. And as you can see here, they have named the terms. E is EMF, R is resistance, G is galvanometer, and T is deflection. Theta is deflection. Okay. Okay, so this is a construction where R is higher resistance box, remember, and S is small resistance box. That means shunt we call it. Okay, by seeing the resistance box only you can say which is a larger resistance box, that you place it in terms of key 1 next to the battery. Okay, then whatever is smaller one, that you place it near the key 2. Okay, so K2. The battery you can connect it over here. Please know the circuit diagram. It's very simple, and you don't have many circuit diagrams over here. Very few circuit diagrams are there. Like first two experiments, same circuit diagram, and for this and one more, like that's it. You don't have much circuit diagram over here. Okay, so you can remember this and name them. Don't forget to label them. R stands for resistance box. S stands for shunt resistance box. Okay, K1 stands for key 1, like keys. You can mention like that. Okay, so don't forget to do that. First observation, EMF of the battery. Okay, you have a battery, right? Okay, over there you'll have 2 volt, 4 volt, 6 volt, right? That itself is a EMF. Okay, so E is directly you can write down like whatever is mentioned there. You don't change for every trials. For one trial, keep it the same. If it is 2 volt, keep it 2. Don't go beyond 6 or 8. Okay, keep it in 2, 4, 6 in that range. You can do that. Okay, so normally I keep it for 2 volt. Then take a trial. Since they don't have any graph, don't increase the number of trials. Okay, you can ask your external examiner like how many readings you need, and that much you can just take it. Normally they'll ask you to take around 3 readings. Okay, so take a resistance, and then there will be a deflection. As you know, for a half a deflection you should remove the shunt, and whatever the shunt and resistance you are getting, you will be calculating this, and finally you will be calculating the figure of merit. Okay, so one thing, understand what is figure of merit means. How much current flows for one division. Normally in a galvanometer, there will be a divisions, right? Like 0 to 30. For per division, how much current can flow? That is nothing but figure of merit. Okay, basically you should be knowing this. Okay, so that's the reason it's SI unit is ampere per division, because SI unit of current is ampere. So how much current is flowing per division is what? Figure of merit. Okay, and galvanometer is the resistance of the galvanometer, we will take it as G. That's the reason its SI unit is in ohm. Okay, so remember its range again. So its range, something in hundreds or something you will get it. And figure of merit also, it depends. It depends from galvanometer to galvanometer. Basically, it will be something in terms of like 1.6 into 10 raised to minus 6, in that range only it will be. Okay, so remember the values, what should be the range of the values. Finally, you can take a mean of it, and average of G and average of K will give you the result. Okay, again when you are doing the average, please show the calculation. Don't forget to show any calculation. Show the calculation, trial 1 plus trial 2 plus trial 3 divided by 3. That gives you the average of G as well as K. And then after you write the calculation, that's the reason we have kept the space blank, because you should fill this space. Don't skip this. It's not like, okay, I know the calculation, I'll do it in my mind. Finally, I'll enter the result. Please don't ever do such mistake. Okay, so please write the calculation, neatly write down trial 1, trial 2, trial 3, what are the calculations. Then as you know that for G equals RS by R minus S, even that calculation you can show. Presentation matters a lot over here. Okay, so then finally the result, you can just write it with the result. Okay, so don't forget to write the result as well. Okay, now moving to the next, conversion of galvanometer to voltmeter I have taken here. There is a conversion of galvanometer to ammeter also, but don't get confused. If you are taking conversion of galvanometer to voltmeter, then what you do, you connect the resistance box in series. Okay, you are learning this in theory also. Here you will be taking a normal resistance box, higher resistance box, and you are not taking any shunt resistance over here. If it is ammeter, then you are taking a shunt resistance where you are connecting it in parallel. But here it's a voltmeter, you will be connecting it in series as well. Again, you have a circuit diagram over here. So first write the principle. Okay, it can be connected by connecting a high resistance in series with it. Whatever I said, no, same thing it is in the principle. Formula again, current is equals N times K, where N is number of division and K stands for figure of merit. Okay, and yeah, this is our main formula. And then this is a circuit diagram. Connected, as I said, galvanometer is always connected with what? Higher resistance box in series. Okay, so this is how you will connect it, and to vary the resistance and all, we need a rheostat. So I'll be connecting the rheostat. Okay, and then battery and a plug key. Here one key is sufficient, and then name them. Okay, now observation. Okay, in this observation matters a lot because there are too much long observation. Okay, you are calculation part is like tabular column is very less. Okay, but observation is like you have too much. Okay, so resistance, as we here resistance will be given. Okay, figure of merit will be given. So don't don't memorize the numbers also, please. Okay, because it will be given. Resistance will also be given. Figure of merit of the galvanometer will also be given for this experiment. Okay, so based on that, number of divisions on either side of galvanometer, where you have 0 to 30, you can just write that division. And what is the current required? I equals N times K. You can just multiply these two. You will get what is the current required flowing through the galvanometer. And what's the maximum voltage to be measured? That I can't say. With your voltmeter, you can check what is the maximum range. Okay, so based on that, you have a value of calculated series resistance and value of observed series resistance. You have that method also, and you have one more tabular column method also. Okay, there are two different methods for this. Whatever you're comfortable, you can do that. Like you have a standard resistance and a voltage, and as you move the voltage and galvanometer will be in the same flow, because that's how you will know that voltmeter is, galvanometer is getting converted. It got converted to voltmeter. Okay, so that's how you will get to know, and then finally you will just check the error. Okay, that's one method is there. So whatever method you are comfortable or what method has been taught for you, that you can do it. Okay, fine. So now next is the frequency of AC. Again, this is the most simple experiment. Okay, so you have a sonometer, right? Sonometer, and then there will be an electromagnet. Okay, so you have a sonometer, you will place the weights, and you have an electromagnet over here. So what happens, electromagnet, as you pass a current, it gets magnetized, demagnetized. That time there will be a resonance which is created. You will be able to hear a very huge vibration or a sound. Okay, so at that particular length, if you take it, and then remaining is calculations. Okay, so as I said, again, please write the principle. Okay, so each cycle of AC, the sonometer is pulled and released twice, and take a frequency of, formula for this frequency is 1 by 4 times root of. Yeah, you can take this also. If not, you have another formula like N equals, okay, N equals 1 by 2L root of, 1 by 2L root of T by M. Okay, you can take this formula also. Later, you can take frequency is half of N. Okay, so yeah, it is like different methods are there, like fundamental frequency mode you can take as per your convenience. Okay, yeah, you have this tabular column, like mass is given, mass attached to a spring. Basically it will be given in like 500 grams and all, each 500 grams. Okay, so try to take more mass. Okay, so you can increase the tension of the wire. So if you start from like 1.5 kg to 2.5 kg, if you take like that, you can take 2-3 readings, it will be sufficient. Okay, 3 readings. And then tension is what? Mass times gravity. Okay, the value of gravity is 9.8. in case if I am taking 1, So then it will be 1 into 9.8. Okay, 1 kg. Please convert it to kg. Don't forget that. So 1 into 9.8 is 9.8. And resonating length. So what length it starts resonating? That length you will be taking it in meters again, because your near sonometer you will be having in centimeter. Don't forget to take that to meters. Okay, basically like a 25 centimeter will be given. So you convert it, directly take 0.25 meters. Okay, and here there's a L square. You don't need L square over here. You can just take a formula, okay, resonating length, and then you can directly take a formula. Okay, so as I gave a formula here, N equals 1 by 2L root of T by M. Okay, where T is tension in the wire, where we got it as 9.8, and M is mass density. Okay, so mass density is also given in the mass density will be given. Okay, it's given like mass per unit length of the wire, the value will already be given. Okay, so you don't have to worry about that. L is what? 1 by 2L. L stands for resonating length. Okay, and then whatever values you are getting, take it a frequency. Frequency of AC is what? N by 2. Okay, so as we know, so as you all know, what is the frequency of alternating current in India? So it is basically 50 hertz. Okay, so you should be getting the values nearly in terms of 50. Okay, so finally once you calculate, you can take an average of N. So finally the answer should be in the range of what? 50 hertz. Okay, fine. So now moving to the next, focal length of concave mirror. Again, it's a very simple experiment. Of course, we are not using an optical bench over here. In case if you are using optical bench also, it's completely okay. So you'll be finding a focal length of concave mirror. So right principle. So what is the principle? Focal length. What is focal length? Write down. And when an image is formed, as you know, whenever an object is placed in between C and F, image is formed beyond C. Or if object is at infinity, image is formed at focus. Just like that, you can write, if an object distance is greater than the focal length, what happens? You get a real and inverted image as well as an enlarged image. So that itself is a principle for this experiment. Okay, and then formula. Okay, you can write a mirror formula. 1 by F equals 1 by U plus 1 by V, where F equals UV by U plus V, and name what is U, what is V, and what is F. Okay, so this is a concave mirror. As you place an object, the image is formed. You can just draw the diagram for that, and then tabular column. Yeah, before that, find the rough focal length of the concave mirror. Okay, so you will get an idea like what will be the exact, like nearly the focal length. Okay, so as I said here now, for every experiment, you should be knowing its final answer. What will be the range of that? Just like that, in case if they are giving you the mirror, find a rough focal length. Okay, so how to find the rough focal length? Just take 1 meter scale. Okay, just take a meter scale, place a mirror on the meter scale, and try to focus the image, any like a window grills or any image, try to focus of that object so that you will get one clear image, right? At that particular point, you just stop and then measure the distance from the wall or any support you can take it. Okay, so that gives you the rough focal length measurement. Okay, fine. So first find a rough focal length, something like 10 centimeter or 15 centimeter, you might get it. So then you will get an idea. Okay, so your mirror is something around in that range. Okay, then you take as you move, you have a lens, so mirror holder here, object like a bulb also they can use, or you can use an infinite distance also. Okay, and then you have a screen where an image is formed. Okay, so based on that arrangement, you will be finding what is U, what is V, and then finally substitute in this formula, the most simple experiment. Okay, and then take the average or mean of it. Okay, finally you will get the answer. Okay, something around 10, 15, if you are getting 11 centimeter also, it is close to that range. So you will get an idea so that you can end the experiment. Okay. Fine. Similarly, focal length of convex lens, the same methodology, but here we will be using a convex lens. Okay, there it's a concave lens. Okay, concave mirror. It's a reflecting, but here it is refracting. That difference you should be knowing. Whereas the similarities are both are converging. Okay, even the concave mirror is converging, and here convex lens is converging. Okay, so this is a finding the focal length, not just a formula. Here you will be plotting the graph. Okay, you have two graphs, right? U versus V, as well as 1 by U versus 1 by V graph you have. So again, here you can just take the principle, almost the same principle only. Okay, but you should tell if object distance should be more than the focal length. Only then you will be getting a real and inverted image. So please practice the principle for all the experiments. Okay, and then you have a formula. Okay, so diagram, even here it is u versus v. Okay, over there you had a focal length formula, right? F equals uv, but here you are not using formula. Okay, here you are finding the focal length using the graph. Okay, so before this, again try to find the rough focal length. As I said, take a scale, take the lens here, it is lens, right? So object should be opposite to the screen. Okay, remember any object or any far distance. So I just place the lens and then try to focus the image of that far distance. Wherever the image is formed, that will be the focal length. Okay, that distance from the lens to the screen. Okay, so that gives you the rough focal length. Please find the rough focal length, then proceed to all the proper thing. Okay, and then yeah, as it is a graph, try to take more readings, at least 5-6 readings you take it, and then use this second quadrant of the graph. Please don't forget here. Why second quadrant? Because okay, because u is always negative. Remember the sign convention, u is negative here and v is positive because image is formed to the right, in the direction of light. But u is always taken against the direction of light. You have learnt in your theory. So please take u minus. That's the reason we use second quadrant. Please don't forget to do this. Okay. So as you take a distance, you will get a curve, something like this. Then what you do, using a protractor or something, take a 45 degree. Okay, and then measure its distance. Okay, I'll take this as O A B. Okay. So what is focal length formula? The distance of OA plus OB by 4. So once you calculate, you should get some values in terms of centimeter. You can end it in centimeter. You need not convert to meter over here. That's okay. You can end it in centimeter. Again here, don't forget to take the axis or units. Okay, the units, whatever you're taking for u, it should be the same for v also. Okay, for example, you have started this as 5, 10, 15. Okay, so 1 unit is how much here? 5 units, right? Around 5 centimeter. Similarly, even here it should be 5 centimeter itself. Okay, you can't take 2, 4, 6, 8 over here, there 5, 10, 15. No, you can't differ the range over here. So unit should be the same for this particular graph especially. Okay, because you are taking a 45 degree mid of that, right? And directly you're using this formula. Okay, so that's the main reason why you are supposed to do that graph in that way. And while plotting a graph also, please write the scale. Okay, x-axis is 1 centimeter is how much unit, and y-axis 1 centimeter is how much unit. Okay, and then y-axis, x-axis, all the coordinate axis. So let the presentation be very neat and clean. Okay, so that's how you impress the external also, so that they will get one confidence like, okay, this person has studied well or prepared well for the exam. Okay, fine. So now finally the result is focal length of convex lenses dash centimeter. Okay, then comes minimum deviation. Okay, so yes, this is a prism experiment. Okay, so here again, principle just mentioned. As you all know, what is angle of minimum deviation? Okay, just write down angle of minimum deviation is angle between an incident ray and emergent ray. Okay, at that condition of minimum deviation, what happens? Angle of incidence is always equal to angle of emergence. Okay, so here, yeah, take a prism, take a tracing of the prism, draw the angle of incidence. Okay, draw the angle of find the angle of incidence and find the angle of deviation. Sorry. Okay, so one thing remember here, angle of incidence. Okay, you should increase the angle of incidence. Okay, increase. For example, I'll take 35 degree, 40 degree, 45 degree, 50 degree, 55 degree. Okay, always increase the angle of incidence. If you are increase the angle of incidence, angle of deviation should decrease. Remember, for example, I'm not giving a proper thing. I'm just taking, I'll take this as 50 degree, 43 degree, 39. Okay, you can see here, angle of deviation is decreasing, right? But again, at one particular time, it will increase. You can see the values over here, 50, 43, 39. Again, it started increasing. Okay, so this is how you should get the values. Once you get the values like this, so as you increase the angle of incidence, what happens? Angle of deviation or delta or d, you can write it. Angle of deviation will decrease, and at one particular point, it will increase. You can see the values here, 50, 43, okay, 39, okay, 39. Okay, let me consider this as 39 degree, and then again it started increasing like 45, 50, 55. This, in case if you're getting such readings, then it's perfect, where 39 is your what? Angle of minimum deviation. Okay, angle of minimum deviation. So basically at this particular angle, what happens? The as what is that, angle of incidence, as you increase, angle of deviation will decrease. Okay, so at this particular angle of incidence will be equal to angle of emergence. Okay, so we can't see that, right? That's the reason we are plotting it here. Okay, through the pin method and all, we are plotting it. Okay, so please remember this graph itself, here we don't have much calculation, so graph carries marks. Okay, so please present the graph also in a particular way, and also the tracing, whatever you are doing also matters. Okay, take around 5 to 6 readings. Once you start getting minimum deviation, then yeah, you can end it. After minimum deviation value, you can just end it. Okay, fine. So finally the result is angle of minimum deviation is dash. And then comes refractive index of glass using the traveling microscope. You should be knowing how to use a traveling microscope. Okay, so principle, yeah, take the principle, like refractive index of glass with respect to the air is ratio of real depth to apparent depth. Just a formula, whatever you have learnt in your theory, the same principle is applied over here. And then take the refractive index formula, write the thing, and then yeah, like value of one mean scale division, number of divisions on 1 year, and what's the least count of it. Okay, so first reading, you will just take it with a plain glass. Okay, and then what you will do, you will just sprinkle some talcum powder or something. Okay, and then you will be taking the readings, and then finally you will be placing the glass. Okay, so you are basically using the glass slab over here. Okay, so whatever, after getting all the readings, reading 1, reading 2, reading 3, then take a difference of it, like R3 minus R1 divided by R3 minus of R2. That gives you the refractive index of glass slab. So remember, what should be the refractive index of glass slab? It should be in the range of 1.5, nearly. Okay, I'm not telling it should be 1.5, nearly in the range of 1.5. So that's the value of glass, refractive index of glass. Okay. Now, next is refractive index of water. Okay, so this is a pin method basically. Okay, even here similar, but there you will be using a traveling microscope. But here you will be using just any, like a pin method, or even a pen or pencil also you can use it. Okay, you will be getting an inverted image when you are seeing a lens. What is that? You will be placing a mirror on the lens. Convex lens you will be using it. Okay, so you will be getting an inverted image. At that particular point you can stop and you can take the readings. Okay, so again the principle is almost the same formula. Okay, so f is a focal length of convex lens, and f dash is a focal length of combination of the lens and water. Okay, so finally you should be getting the focal refractive index of a liquid. Okay, liquid, what we are using is water. So the refractive index of water is in the range of 1.33. It should be nearly equal to 1.33. Please remember this value. Okay, if you remember, it's easier for you to finally end the result. Okay, refractive index of air is 1. Refractive index of water is 1.33. Refractive index of glass is 1.5, nearly. Okay, in water it can be like a different types of liquid, but basically for water it is 1.33. Okay, so that ends this. And then you have forward bias and reverse bias. Okay, basically they'll be giving a kit over here, but here please draw the circuit diagram for this. Okay, many students will not draw the circuit diagram here, but try to, please draw the circuit diagram. Of course there is no connection for you to do, it's ready kit, but you will have to draw the circuit diagram. Okay, so then yeah, when, as you know, when a diode is forward biased, okay, so what happens, there will be a less resistance and all, and there will be a cut in voltage. Okay, so forward bias means what? When you are connecting a positive terminal of diode to positive of a battery, and negative terminal of a diode to negative of a battery, that is forward bias. And then you have a reverse bias. Reverse means you are connecting it in a opposite manner, where positive terminal of a, positive of a diode is connected to negative terminal of battery, and negative of diode is connected to positive terminal of battery. Okay, so that's how we will be doing. Basically these are two different experiments, like forward bias and reverse bias. Okay, again here take the readings. Okay, you will have to just move the knob of what is that, forward bias and reverse bias knob. As you move the knob, you will be having a voltage and current reading. Okay, voltage and current reading. So take a voltage versus current, and check what in current is in milliamps or microamp. Please check. Basically, you will have in micro for reverse, and here milliamps you will be having it. So please check with what it is, milli or microamps you will be having. Okay. Fine. As you take the values, so as you can see here, current will be like, voltage will be increasing. At one particular point, current starts increasing. Okay, so that voltage, what you call it as like a breakdown voltage, okay, or a knee voltage we call it. So the expected graph is you will be taking a first quadrant for the forward bias. Okay, so as I said, you will be taking I along y axis and V along x axis. Okay, so as I said, as you increase the voltage, current will be zero, guys. Okay, 0 0 0. At one particular point it starts increasing. Okay, so which point it starts increasing, that gives you the breakdown voltage. Okay, yeah, or a cut-in voltage, you can just take like that, as you can see here. Okay, so yeah, so here you'll have to plot a graph, and please draw the circuit diagram. Okay, of course you are not connecting it in this way, but remember the circuit diagram. Yeah, this is positive terminal of diode, this is negative terminal of diode. As you can see, it is connected, positive is connected to positive of battery, negative is connected to negative of battery for forward bias. In reverse bias, just interchange. Okay, that's it. And then finally, what is a cut-in voltage, you can mention. In case if they're not asking you to mention cut-in voltage, you can just mention like this, the IV characteristics of the forward bias is plotted. Okay. So yeah, this is also the same thing, forward, and this is for a reverse bias. Okay, in reverse bias, take a third quadrant of the graph. Okay, so again, y-axis is I and x-axis is V. Okay, even here, as you increase the voltage, what happens? Current will be zero. Okay, and at one particular point it starts increasing. Okay, some cases it will be increasing also, but in some cases it will be constant because the saturation current would have reached. Okay, it varies from kit to kit. Okay, so you don't have to worry about that. So the nature of the graph should be in this way. Okay, so this is a what is that, for a reverse bias. Okay, as I said, some cases it will lead to a saturation, and you can measure what's the saturation current. Finally, you can put a result here. The reverse saturation current for the given diode is in terms of dash. Okay, dash ampere. Fine. Okay. Yeah, thank you all. In case if you have any doubts or something, please drop your comments in the comment section. Okay, thank you for watching.